Alright, this video is trying to basically highlight the factors that affect acid strength. So the key thing is to remember that anything that makes an H easier to remove, weakening the bond where the H connects to the acid, will cause more H's to break off, which will increase the strength of an acid. So when we look, here are some key things. Bond strength, obviously. The weaker the bond, the more acidic an acid's going to be generally. There's a couple things that are going to basically influence that. I'll show you on the chart how that works. Basically, it's really going to be dependent on how electronegative something is or the size of the ion. The other issue is bond polarity, basically the distribution of the electrons. If the electrons are fairly evenly distributed, the bond won't be polar. A highly polar bond between hydrogen and another atom makes it easier for it to snap off. So the more polar the bond, it's easier to snap off, or the bond strength. The weaker the bond strength, the easier it is to snap off. So if we look right here, think about these four acids right here in group 7 in the periodic table. Radius is directly proportional to acid strength. The larger or the farther the atoms are from each other, they're easier to separate. So if you know the trend for atomic size is as you go down a group in the periodic table, the ions get larger. So if you take a look at HF versus HI, HI is considered a stronger acid. The reason why is HI has a longer bond, greater ion. What that does is it decreases the strength of the bond, makes it easier for it to snap the H off, versus HF, which is a much shorter, smaller bond, is harder to snap the H off, which makes that the difference between that being a weak acid and that being a super strong acid. So bond strength is the first thing you look at, and the key part of that is atomic radius. If you look here, we already talked about that. Bond strength decreases as you go this way because of atomic radius. So if you're comparing these two acids, H2Te would be stronger than H2Se simply because bond strength. The other thing you have to keep in mind is electronegativity. The more polar a bond, the easier it's going to be to snatch the H from there. So if you look at H2S versus HCl, HCl is considered a strong acid. H2S is not considered a strong acid. As you go this way in the periodic table, so if you're talking about two acids from the same group, the same elements that form the basis for the acid, the more electronegative the element is, the acidity of the acid is going to increase, or the strength of the acid. The last situation is when you talk about oxoacids. Oxoacids deal with acids that have a hydrogen directly bonded to an oxygen and then a base element. So if you think here a central element, you take a look at HOCl, base element Cl, right? As you add oxygens, the number of oxygens increases. You increase the electronegativity pull of the central atom. So you're increasing the force. So as I increase the number of oxygens finally getting to 4 here, I actually increase the strength of the acid. So if you have, it's the same element, chlorine, 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 and chlorine, but as you increase the number of oxygens, you weaken the bond between the hydrogen and the oxygen, making it easier to snap off. That's why when we compare H2SO4 versus H2SO3, H2SO4 is considered a strong acid. This is a weak acid. It has to do with the number of electrons. Look right here. You have the same kind of thing we looked at, HOCl versus with the 4 oxygens on there, weakening this bond because the electronegative force is pulling on it, weakening the H bond. What if you have different elements but the same number of oxygens like you have here on the top? Then it goes by totally based on electronegativity. If you look at the differences in electronegativity, HOCl, since it has Cl as its central element in the oxo acid, greatest electronegativity will have the greatest pull here, will be easiest to take that H off, versus I, which doesn't have as high of electronegativity as chlorine, won't have as great of a pull on it, making that H harder to remove, making this the weaker acid, this would be the stronger acid, and this would be the middle acid, based on the idea of electronegativity. Those are the factors that actually have an impact on the strength of an acid, the structure.